Question number 15:1.
A and B, when divided by 7 and 6 respectively, leaves remainder P and Q respectively. What is the maximum value of P and Q? Option A 5, option B 6, option C 12, option D 11. Consider the first sentence. That is, A and B, when divided by 7 and 6 respectively, leaves remainder P and Q. Okay, that is A when divided by 7. That is A when divided by 7. Okay, then leaves remainder P. You will get remainder equal to P. Similarly, B divided by 6. B divided by 6. Then you will get remainder Q. Here quotient is not given. So let us assume x and y be the quotient. X and y be the quotient. That is, let us assume when you divide A by 7, then you will get quotient equal to x. Similarly, when you divide B by 6, you will get quotient equal to y. Now, by Euclid division lemma, we have A equal to BQ plus R, 0 less than or equal to R less than B. So, by applying this, the first division we can write it as dividend. Here dividend is A. A equal to 7 into X, 7 into X plus P, remainder, plus P. Here value of B is 7. So, 0 less than or equal to R less than 7. Okay. Similarly, here B, here dividend is B. B is equal to 6 into Y. 6 into Y plus remainder is Q. Here value of B is 6. So, 0 less than or equal to R less than 6. Now here what is R? Remainder P, right? So, 0 less than or equal to P less than 7. Similarly here remainder is Q. That is 0 less than or equal to Q less than 6. Okay. So, value of P is equal to 0, 1, 2, 3, 4, 5 and 6. Similarly, value of Q equal to 0, 1, 2, 3, 4 and 5. Okay. So, here maximum value of P is equal to 6. Similarly, maximum value of Q is equal to 5. Okay, and here the question is, what is the maximum value of P plus Q? So, maximum value of P plus Q equal to 6 plus 5 equal to 11. That is option D.
Question number 15:2.
Explain why 15 into 3 into 2 plus 2 is a composite number. Option A, it has 1 factor. Option B, it has 2 factor. Option C, it has at least 3 factor. Option D, none of this. Here number is 15 into 3 into 2 plus 2. Okay. First we can find out the factors of this number, prime factors of this numbers. Okay. Before that, consider an example, that is A into B into C, okay, plus C. This one we can write it as A, B, C plus C. C is common, right? So you can take it out. That is C into AB plus 1. Okay. Similarly, here 15 into 3 into 2 plus 2. 2 is common, right? So take it out. That is equal to 2 into 15 into 3 into 1 plus 1 equal to 2 into 15 into 3 45 into 1 45 plus 1, that is equal to 2 into 46. 2 is a prime number, isn't it? So we can factorize, we can find out the prime factors of 46. 46 to 23. 23 is a prime factor. So this one we can write it as 2 into 23. 2 into 23 equal to 2 raised to 2 into 23. Okay. So here factors are 2 and 23. That is 2 and 23 are the prime factors of this number. So here we can say that other than 1 and the number itself, here factors are 2 and 23. And we know that by definition, composite number is a whole number that have more than 2 factors. That means it should have at least more than 2 factors, means at least 3 factors, right? So here and here how many factors? 1 and the number itself, then 2 and 23, 4 factors. So here option is C. It has at least 3 factors.
Question number 53.
The number 3 minus root 3 by 3 plus root 3 is option A rational, option B irrational, option C both, option D none of this. Here given number is 3 minus root 3 by 3 plus root 3. 3 minus root 3 by 3 plus root 3. First step, rationalizing the denominator. That is multiplying numerator and denominator with the conjugate of the denominator. That is 3 minus root 3 by 3 plus root 3. Here denominator is 3 plus root 3. So its conjugate is 3 minus root 3. 3 minus root 3 by 3 minus root 3. Okay. Now 3 minus root 3 into 3 minus root 3, that is a minus b into a minus b equal to 3 minus root 3 whole square by here 3 plus root 3 into 3 minus root 3, that is a plus b into a minus b. A is 3 and b is root 3. A plus b into a minus b is a square minus b square. So a square, that is 3 square minus b square. B is root 3. Root 3 square. Now what is a minus b whole square? A square, that is 3 square minus 2ab. 2 into a is 3 into b is root 3 plus b square, root 3 whole square. Okay. By 3 square is 9 minus root 3 whole square is 3 equal to 3 square 9 minus 2 into 3 6 root 3. 6 root 3 plus root 3 square 3 by 9 minus 3 is 6. Next 9 plus 3. 9 plus 3 is 12 minus 6 root 3 by 6. Here 6 is common, so take it out. 6 into 2 minus root 3 by 6. 6 and 6 get cancelled. Answer is 2 minus root 3. And we know that root 3 is an irrational number, which implies 2 minus root 3 is also an irrational number. So answer is option B. 53, option B.
Question number 54.
X is called irrational if it cannot be written in the form dash, where p and q are integers, and dash. Option A, p by q, p not equal to 0. Option B, pq, P not equal to 0. Option C, P by Q, Q not equal to 0. Option D, P by Q, Q equal to 0. Now we know that what's the definition of rational number? A number which can be written in the form P by Q where Q not equal to, denominator not equal to 0, right? So what is irrational number? A number which cannot be written in the form P by Q where Q not equal to 0, right? By definition we know that rational numbers are numbers which can be written in the form P by Q where P and Q are integers and Q not equal to 0. And irrational numbers, numbers other than rational number, means numbers which cannot be written in the form P by Q where P and Q are integers and Q not equal to 0. So it cannot be written in the form, it is irrational number. It cannot be written in the form P by Q where P and Q are integers and Q not equal to 0. Isn't it now? So option is C.
Question number 55.
The product of the HCF and LCM of the smallest prime number and smallest composite number is option A 2, option B 4, option C 6, option D 8. The product of the HCF and LCM of smallest prime number and smallest composite number. Now which one is the smallest prime number? Smallest prime number is 2 and smallest composite number is 4. Okay, so first we can write on the factors. 4 you can write it as 2 raised to 2. Okay, now next find out the HCF and LCM of 2 and 4. HCF of 2, 4. What is HCF? HCF is the product of the smallest power of the common factor. Here 2 is the common factor, right? And smallest power is 1. So HCF is 2. Next LCM of 2, 4. LCM is the product of the highest power of each factor involved. So here 2 is the only factor and highest power is 2. That's equal to 4. So LCM of 2, 4 is 4. Question is to find out the product of the HCF and LCM. That is HCF of 2, 4 into LCM of 2, 4. HCF is 2 into LCM is 4. That answer is 2 into 4, 8. Option D. Next, question number 56. The LCM of two numbers is 1800. Which of the following cannot be their HCF? Option A 600, option B 900, option C 200, option D 400. Given that LCM of two numbers is 1800, let two numbers be A and B. Then as per question, LCM of A, B equal to 1800. Now the question is, which of the following cannot be the HCF? Okay. Now what's the relation between LCM and HCF? We know that LCM is always a multiple of HCF. That is LCM of A, B is equal to X into HCF of A, B, a multiple of HCF, right? Now we can check this condition with each options. Okay, first A 600. Okay, LCM is 1800. 1800 equal to X into 600. HCF is 600. So X equal to 1800 by 600 equal to 3. Implies option A can be HCF. Okay, now consider second option. Second one is 900. 900. LCM of A comma B 1800 equal to X into HCF is 900. So X equal to 1800 by 900 equal to 2. Implies option B can be HCF. Now check with option C. Option C is 200. So LCM of A comma B, that is 1800 equal to X into HCF of A comma B 200. Okay. So X equal to 1800 by 200 equal to 9. Which implies option C, that is 200, can also be the HCF of the given numbers, given two numbers, right? Now next option D is 400. 400. LCM of A, LCM is 1800 equal to X into HCF is 400. So X equal to 1800 by 400, 9 by 2. It is in decimal form, right? 9 by 2 is 4.5. So it cannot be the HCF of given two numbers. Okay. So answer is option D. Question is to find out which of the following cannot be the HCF. So 400 cannot be the HCF of two numbers with LCM 1800. Next, question number 57. Without actually performing the long division, state whether the following rational number will have a terminating decimal expansion or a non-terminating decimal expansion. Question is 23 by 8. Okay. Step 1. Write the given number in its simplest form. Given number is 23 by 8. 23 is a prime number, right? So it is in its simplest form. Now step 2, reduce the denominator into its factors. Denominator is 8. So 8 equal to 8, you can write it as 2 raised to 3. We know that if the factors of the denominator is in the form 2 raised to m into 5 raised to n, then the number is terminating decimal, right? Here denominator 8 equal to 2 raised to 3. This we can write it as 2 raised to 3 into 5 raised to 1. Okay. Sorry, 5 raised to 0. Because we know that a raised to 0 is 1. Any number raised to 0 is 1. So here we can write it as 5 raised to 0. So here we can say that denominator is in the form 2 raised to m into 5 raised to n, where m equal to 2 raised to m, right? So 2 raised to 3. M equal to 3 and n 5 raised to 0. So n is equal to 0. So here the denominator 8 can be expressed in the form 2 raised to m into 5 raised to n. So the number is a terminating decimal. So answer is option D. Question number 58. If P, Q are two prime numbers, then LCM of P, Q is option A 1, option B P, option C Q, option D PQ. We know that prime numbers are the numbers which cannot be divided by any number other than 1 and the number itself, right? So it's given that P and Q are prime numbers. So P can be divided only by 1 and P. Similarly, Q can also be divided by 1 and Q. That means factors of P is 1 and the number itself, 1 and P. Similarly, factors of Q, 1 and Q. Now LCM of P, Q equal to, how can you find out the LCM of P, Q? That is the product of the highest power of the each factor involved. So 1. 1 into next P. P into Q. That is equal to PQ. Okay. So option is D. PQ. Next, question number 59. For some integer m, every odd integer is of the form option A m, option B m plus 1, option C 2m, option D 2m plus 1. For some integer m. So m can be even or odd. But if you multiply 2 with this m, then we'll get 2m. 2m will be an even number, right? For example, consider an odd number 3. Okay. If you multiply it with 2, then you will get 2 into 3 is 6, which is an even number. Similarly, consider an even number 4. If you multiply it with 4, then you will get 8. Again, it's an even number. So first step is multiply 2 with this integer m. That is 2 into m is equal to 2m, which is an even number. Question is, for some integer m, every odd integer is of the form. You want to find out the format of odd integer. If 2m is an even number, then the next number, that is 2m plus 1, will be odd. Isn't it? That is consecutive numbers. For example, here 3 is odd, then 3 plus 1, 4. 4 is even. Then 4 plus 1, next 5, that is odd. Similarly, if 2m is even, then 2m plus 1 is an odd number. So option is D. Question number 60. A rational number in its decimal expansion is 327.7081. What would be the prime factors of Q when the number is expressed in the P by Q form? Option A 2 and 3, option B 3 and 5, option C 2, 3 and 5, and option D 2 and 5. Here given number is 327.7081. That is, this number is having terminating decimal expansion. And we know that for terminating decimal expansion, the factors of the denominator is in the form 2 raised to m into 5 raised to n. So here prime factors are 2 and 5. 2 and 5. Okay. And here question is, what would be the prime factors of Q? Q means denominator. When the number is expressed in the P by Q form. Q is the denominator. So prime factors are 2 and 5. Option D.